Welcome to another episode of Tech Talk, where we dive deep into the fascinating world of coding, software, and everything tech. Today, we're exploring a really cool concept that's helping to shape the future of programming: sandboxing foreign code in a programming language called Verona. Now, if you're wondering what that means, stick around because it's a game changer. So let's kick things off. Imagine you have a strong, reliable fortress. What if you could invite guests over safely without fearing they'd plunder your treasure? That's essentially what sandboxing does for code. It allows untrusted libraries to run in isolation from your precious codebase, keeping everything safe. In Verona, this mechanism has been designed to ensure that any unsafe code can only run within this highly controlled environment. The primary aim? Security. Security, security. This means that even if an attacker manages to load untrusted code, their access is strictly limited. They can't mess with the parent process or access global resources unless explicitly allowed. Let's break down some of the lingo so we're all on the same page. In the world of Verona, the parent process is the trusted code that wishes to load potentially harmful libraries. The child process runs this untrusted code, separated from the rest of your system. And then there's the sandbox, which is the magical border around the child process, allowing communication and resource sharing in a protected way. You might be thinking, how does this actually work? Well, it creates a shared memory region between the parent and the child processes. Picture a very secret vault where both parties can see the same treasure chest, but they can only access what's allowed. The parent can manage memory and resources, while the child is kept on a tight leash, accessing only what's permitted. But let's get to the fun part, the security aspects. The threat model that Verona operates under assumes that any library loaded could potentially be untrusted. An attacker could, theoretically, execute arbitrary code in this sandbox. However, if they try anything shady, they're stuck behind some heavy security measures. They can't alter the parent's memory, launch denial-of-service attacks, or access restricted files. It's like keeping a mischievous raccoon at bay with a locked cage. And here's something interesting. The current code hasn't been tested at scale, so it's still a work in progress. Developers are constantly modifying it to improve security while implementing features. What does this mean for you? If you're a programmer, especially in fields dealing with security or software engineering, you could potentially contribute to this project by enhancing its security features or even creating more abstraction layers. As we wrap up today's discussion, a few key insights stand out. Sandboxing in Verona is an innovative approach to isolating untrusted code. It provides a flexible architecture that balances functionality and security, ensuring that risky code runs safely. So here's a thought for you. With technology evolving rapidly, how critical do you think sandboxing will become in our development processes? What other applications can you envision for such a mechanism? Thanks for tuning in to Tech Talk today. If you enjoyed this episode, be sure to subscribe for more insights into the ever-evolving tech landscape. Until next time, stay curious and keep exploring.